The Hardy-Weinberg principle. The Hardy-Weinberg principle is used to predict the frequency of alleles and their associated genotypes and phenotypes in a population. Now, a quick reminder, in terms of alleles, we can have a dominant allele or a recessive allele. As for genotypes, we could have two dominant alleles creating a homozygous dominant genotype, or we could have a homozygous recessive genotype, or we could have a heterozygous genotype. Now, the Hardy-Weinberg principle has a lot of calculations, and they mainly involve these two equations. The first one is P plus Q equals 1. This tells us that both alleles for a particular gene will always add up to 1. For example, we can represent P as big F and Q as little f, and it doesn't matter which way around you do it. As for genotypes, we use this equation. P squared represents big F. 2pq represents the heterozygous, and q squared represents two small f's in this case. And again, all the genotypes also add up to 1. So we have one equation for alleles and another one for genotypes. Okay, let's do a practice question. Now, I would recommend you pausing the video and having a go yourself. So, a species of plant has either blue flowers or yellow flowers. The allele big B, blue, is dominant and has a frequency of 0.3 in this population. What is the frequency of the allele small b, yellow flowers? So we're looking for alleles. If we bring back our two equations, the one on the left was to do with alleles, and the one on the right was to do with genotypes. Since we want to look at alleles, we can completely ignore this equation. So we have P plus Q equals 1. We'll say that big B is equal to P, and it has a frequency of 0.3. As for small b, which is equal to Q, we're not sure what its frequency is. However, we know that P plus Q equals 1. In this case, 0.3 plus Q is going to be equal to 1. So therefore Q is 1 minus 0.3, which is going to be 0.7. Let's try another question. There are two alleles for fur color in rabbits, big R and small r. And from these two alleles, 3 genotypes. If the frequency of the genotype big R is 0.36, what is the frequency of the allele small r? So first of all, let's write down that P is going to represent big R and Q is going to represent small r. We're looking for the frequency of an allele. So once again, we're going to need the equation P plus Q equals 1. We want to work out Q, so that means we need to work out P. Our goal is to work out the value of Q, which represents small r. However, we haven't been given P. Instead, we've been given a genotype, big R, and that's 0.36. So we can say that big R is equal to P squared, and that is equal to 0.36. Taking the square root of both sides would leave us with P equals 0.6. We can plug this into here, and since P plus Q equals 1, if P is 0.6, that means Q must be 0.4. Question 3. The allele for large spots, represented by capital E, in leopards is dominant to small spots, represented by small e. In a population of leopards, the frequency of the genotype big E is 0.34 and big E small e is 0.27. Find out the frequency of the genotype EE. So once again, we're going to write down that P is going to represent big E and Q is going to represent small e. This time we're looking for a genotype. So that means we're going to need this equation, P squared plus 2PQ plus Q squared equals 1. Big E 0.34 is P squared. So we know the value of P squared. And big E small e is the heterozygous genotype. So now we also know the value of 2PQ. However, we don't know the value of Q squared, which is small e. We know, however, that all three genotypes must add up to 1. So we're going to add the 2 on the left, giving us 0.61 plus Q squared equals 1. And therefore Q squared is going to be equal to 0.39. Question 4. A species of plant has either red flowers or white flowers. The allele big R red is dominant and allele small r white is recessive. The frequency of the genotype big R small r is 0.48 and small r is 0.16. What is the frequency of the red flower phenotype? So as always, we're going to say that P is equal to big R and Q is equal to small r. We want to work out the frequency of the red phenotype. So from the three different genotypes, these two have red phenotypes, or red flowers. And this genotype will represent white flowers. So again, since we're talking about genotypes and phenotypes, we're going to require this equation. And we can see how each component of the equation matches with the genotypes. We already know that 2PQ is the heterozygous and the frequency is 0.48. And small r is equal to Q squared with a frequency of 0.16. Since they add up to 1, P squared must therefore be these two added together and take away from 1, which is equal to 0.36. So the red flowers is P squared and 2PQ. So in total, that's going to be 0.84. Because remember, in this question, they're asking what is the frequency of all the red phenotypes, which means both of these genotypes have to add together. Question 5. The frequency of cystic fibrosis in the population is approximately 1 in 2,500. Calculate the percentage of carriers in this population. So we're going to represent cystic fibrosis with the letters big F and small f. If someone has the dominant allele, they will be healthy. As for the small allele, that will lead to cystic fibrosis. So we want to calculate the percentage of carriers, individuals that have big F and small f in the population. So again, we're going to be looking at genotypes and we're going to need this equation. And specifically, we're trying to work out the value of 2PQ. However, we haven't been told the value of P or Q. Instead, we've been given the information on a number of individuals who are suffering. So 1 in 2,500 individuals have 2 small f's. In other words, have Q squared. So that gives us Q squared is equal to 0.0004. Taking square root of both sides gives us Q is equal to 0.02. That means P must be equal to 0.98, since P plus Q equaled 1. Okay, so we know the value of P and Q. Now we can work out the value of the heterozygous genotype. So 2 times P times Q, which is 2 times 0.98 times 0.02. And that equals 0.039. The question wants this as a percentage, so we'll just times it by 100 and the answer is 3.9%. Okay, now we'll look at some other exam-style questions on Hardy-Weinberg. In particular, you'll see questions like this, and this quite often. Now, before we answer these, let's look at the principle behind the theory. So, the Hardy-Weinberg principle states that if you have a population with a set frequency of alleles over several generations, that frequency of alleles should remain constant, providing the following conditions are met. Number one, there have been no mutations in the population. Number two, there is no selective advantage of one allele over the other. In other words, individuals that carry either allele will have the same chance of survival. Number three, the population has to be a large one. Number four, individuals within the population are mating at random. And number five, there is no migration. This includes emigration or immigration. So that means new individuals have not entered the population bringing their new alleles, or individuals from this population have not left, reducing the frequency of their alleles. Okay, so let's look at this question. Give two assumptions that must be made when using the Hardy-Weinberg equation. Well, instead of two, how about 5 assumptions? What does the Hardy-Weinberg principle predict? It predicts that the frequency of alleles in a population will remain constant over generations, providing the following conditions are met. And finally, what does the Hardy-Weinberg principle predict about the frequency of the T allele after another 10 generations? Now, I haven't included the information that comes along with this question, and I've left it out on purpose because the point is, if you look at this question, it's something that's very common about the Hardy-Weinberg principle. So the answer is that the frequency will remain the same. And so we have now completed the Hardy-Weinberg principle. Hey guys, if that video helped you, support our channel by liking, subscribing, and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at ExamQA.com, where I will personally be there to help answer your questions. Mohammed signing out.